In this video, we're going to use Minitab to test the claim about two samples. The first example that we're going to do is example 2 from our two-proportion video. Among 343 infants using bed nets, 15 of them developed malaria. Among 294 infants not using bed nets, 27 developed malaria. We're going to use a 0.01 significance level to test a claim that the incidence of malaria is lower for infants using bed nets. So here our claim is that P1 is less than P2. Our null hypothesis is always that P1 is equal to P2, so our claim is going to end up being the alternative. So the alternative hypothesis is going to be that P1 is less than P2. So in order to perform this test, we click on Stats, Basic Statistics, and then we go down to Two Proportions. Here we're going to need to fill in our summary statistics, so make sure that you have summarized data selected. In the first column, we're going to enter in the information about those infants using bed nets. So 15 developed malaria, that was out of a total of 343. 27 developed malaria out of the infants that were not using bed nets, and that total was 294. Click on Options. Here you need to change your confidence level, and so we're doing a 0.1 significance level test. That means our confidence level is 99. The hypothesized difference will always just remain 0, and then we need to change our alternative because our alternative is less than. And you also want to make sure that you use the pooled estimate of the proportion in this last drop-down menu. And then click on OK and click on OK again. On top here it gives you the information summarized about your samples. And then down on this line here we have our alternative hypothesis. It gives us our test statistic, and then it gives us our p-value. Our p-value is less than alpha, so that tells me that I'm going to reject the null hypothesis that the two proportions are equal to each other, and that means that I have sufficient evidence to support my claim that that P1 is less than P2. So the incidence of malaria when using the bed nets is less than the incidence without the bed nets. Next, we're going to use Minitab to test the claim about two means. And to do that, we're going to open up a data file. We're going to look at the cigarette data file. And we're going to test the claim that the mean nicotine level in the King cigarettes is equal to the mean nicotine level in the menthol cigarettes. So here we want to click on Stat, Basic Statistics. We're looking at whether or not there's a difference in those two means or not, and so we want a two-sample t-test here. And we have each sample in its own column, so select that one from the first drop-down menu, and then tell Minitab where to find the data. So C2 and C5. Click on Options. We're going to do a 0.05 significance level, so we're going to keep our confidence level at 95. The hypothesized difference almost always is going to remain 0. We're testing the claim that the means are equal, and so that means our alternative will be that they are not equal. So you can just click on OK and click on OK again. Up top again, it gives you the summarized information. You have the mean and the standard deviation, and also n for both sets of data. Down below, it gives you your alternative hypothesis, it gives you your test statistic, and here it gives you your p-value. Since our p-value is less than alpha, we're going to reject the null hypothesis. Our null hypothesis was that the two means were equal to one another, and so this tells me that we are rejecting that claim that they're equal to one another. There most likely is a difference between these two means. Next, we're going to take a look at paired data. In paired data, the two numbers are going to be coming from the same individual. So there are two different types of tests that we're doing about means. One is taking the mean of one set of data and comparing that to the mean of another set of data. The other is when you get two numbers from the same individual, and so they're matched up. Or maybe you're comparing the difference between something in a wife versus their husband, but in some way each data value is paired up with another data value in another set. And so you just need to be careful of that. Are they paired up or are they not paired up? And so here we're going to take a look at another example from our lecture video. And here the author had recorded actual temperatures along with the temperatures that were predicted. And here we actually we just computed a confidence interval, but we're going to test the claim about whether or not they're different. So here we need to enter in our data. So now I have the data entered into Minitab, and in order to perform this test, we're going to go click on Stat, Basic Statistics, and now this time we have paired data. So we want to select paired T, and each sample is in a column, so we want to select that. You can also enter in summarized data if that's what you happen to have. So I want actual and the forecasted temperatures. Click on Options, and here we did a 99% confidence interval, so we'll stick with that. So that would be a 0.01 significance for our test, but when we enter it in here, it's going to be a 99 confidence level. The hypothesized difference stays 0. And here we were testing to see if there actually was a difference or not. And so that difference could be bigger or less, so we want to keep it as not equal to. So click on OK, click on OK again. And so again, it gives us some summarized information on top, and then on the last line here, it's giving us our alternative hypothesis. Here is our test statistic, and here is our p-value. So our p-value this time is greater than alpha, which tells us that we are going to fail to reject the null hypothesis. And so we can conclude that the temperatures are in fact equal to each other because we're going to fail to reject the null hypothesis that they're equal to one another. So that's it for this video. Let me know if you have any questions, and I hope you're all having a great day. Thanks.